We are going to learn about use callback and use memo, but let's see like what are the things that we are going to cover today, right? So what I'm thinking is like maybe these are the things that will be more useful. Like we'll talk about performance, we'll talk about what are they and how are their syntaxes. Then we'll talk about the usages, examples, and finally when not to use, right? So that's something that we're going to talk about. So very first thing that we're going to talk about performance is what exactly performance means. So when you are actually designing and developing an application, you really don't want the application to be very sluggish. Somebody clicking on a button or typing something into the input text box, you don't want the response to be very slow at least every time. Correct? So that is where the performance thing is like as a developer we need to take care of in our code. Now React itself as a UI library takes care of lot of performance improvements. We really don't have to over engineer thing many times. But there could be a situation where you are invoking a function which is taking a lot of time, or you are making an API call which takes a lot of time, and maybe you have to execute that function or you have to make that API call only once. You don't have to do that on every component re-render. So you have certain ways now in React to control that, where you can use some kind of cache value, some kind of saved value, in-memory value instead of executing those function, executing those calls again and again. That's why use callback and use memo will be really useful. Okay, that's why we talk about the performance thing. Now, the performance stuff having is another side of the coin. If we overdo, we are going to kill it. We are going to talk about in the last section of the video when you talk about when not to use callback and use memo. Okay, so the next thing that we're going to talk about, what are these? So these are two hooks. We have spoken about few hooks already. We have spoken about say use state, use effect, and use ref, things like that. Use callback and use memo are again two hooks. If these are two hooks, it means that these are same old JavaScript function which can take certain argument and can do certain action, probably do some state management and things like that, and can return something, right? That's the main fundamental of hooks that we have learned from the previous videos. All right. Now in JavaScript, the functions are first class citizens. Okay. What exactly first class citizens mean? First class citizens means the functions can be treated like any other values. It means that you can actually assign a function to a variable, you can pass the function as an argument to another function, you can return a function from another function, you can do everything. In some languages this might not be the case, but in JavaScript it is the case, and that is why JavaScript is very powerful. Okay, if you want to learn this topic very depth, there is a video called Higher Order Functions that I have created. You can just go ahead and check a look into it. The link is in the description of this video already. Please check it out. All right, so coming back to our topic today. Now, what are they? These are two hooks, but to solve some kind of performance problem, we'll see like how are they going to solve the performance problem. But before that, let's see what are the syntaxes. How do they look like? How does these hooks look like? Here goes the syntaxes of these two hook. So use callback, that's the use callback hook name, and then it takes a function, okay, and an array, okay. The function is something where the things happen. Basically, you want to kind of do some kind of calculation, or you want to do your own logic inside this particular function. And this dependency array is similar to that what we have seen in the use effect, right? You used to pass a dependency array, and if the dependency changes, you used to call back in the use effect. Similarly, in the use callback case, also if the dependency changes, use callback is doing to something for you. Use memo, exactly same thing, same signature. It takes a function and the dependency array. Now you might have a question, okay, so it's the same signature, why there are two things? Okay, so there is a subtle difference, and this difference is very important for you to understand. In case of use callback, if the dependency array changes, use callback is going to return this function itself. Now with taking this function, whatever has to be done, it is completely up to the programmer, that what they want to do. But in case of useMemo, if the dependency array changes, useMemo will execute this function and then return the value of it. In this case, the function itself gets returned, the callback function itself gets returned, so why the name is useCallback. In this case, the function gets executed and the value gets returned, so why it is like useMemo. This is a very big differences. Okay, that is very cool, but doesn't it really sound similar like what we have seen before in use effect? Do you remember the use effect hook? Okay, so let me just put the syntax over here so that you remember. This is use effect. This is how the use effect look like. What used to happen in use effect? So what used to happen is basically whenever the dependency array changes, useEffect used to execute this particular function, which we used to call as callback function. So whatever write inside this callback function, that gets executed, and that is what we used to call as a side effect. The side effect could be making a database call, an API call, reading from local storage, or IO operation, or whatever it is, right? Those are the side effects. We have learned about this in the previous videos about useEffect. So if the dependency changes, useEffect used to execute this particular thing. But there is one catch here. useEffect will execute. useEffect will execute on the re-render, and it will execute basically irrespective of whether this particular thing is kind of very heavy or it is going to take a lot of time. It doesn't really care about it, and there is not much control at this point of time for us to kind of take that call, like, what is getting executed as part of callback function, how heavy it is, and how to optimize those. So to optimize that one, to make sure that the optimization happen, we have two things now. One is useCallback and useMemo. In case of useCallback, this particular fn will be always same, or this particular value after executing the fn, the function will be always same until unless the dependency array changes. So it means that React is now never going to recompute this particular function, never going to re-execute this particular function until unless the dependency array changes. What it means is a big thing. It means that if this function is something which takes a lot of time, if the dependency array doesn't change, this particular function will not be executed on every component re-render. So it would have got executed once. The value will be kept in memory. So for the same dependency, same value will be returned to you. It is not going to execute this function again and again. This is a big thing. This is a big thing, because if this function is going to take, say, 3 seconds to execute, you are going to save the 3 seconds on every render, because it is not going to return you another freshly executed value. Okay, but if the dependency array changes, that is the time it is going to recompute. It is going to re-execute this thing and then send the new return value to you, right? So that makes sense, because the dependency array changes and this is what is getting changed. So this is a very, very powerful thing. Same thing for the use callback as well. If the dependency changes, then only the new instance will be returned back to you, until otherwise the same instance will be returned back to you. So use callback, useMemo is a performance improvement over what we have seen in useEffect, but we have to see how to use them better way. When it comes to the usages of useCallback and useMemo, these two phrases you will be hearing again and again. One is called referential equality, another is called expensive execution. We'll explain what are those. So expensive execution is something like a function is going to take a lot of time to execute. It's an expensive function to execute. That's as simple as that. And we have discussed that in the case of useMemo, it is going to cache the value of it so that it tackles the expensive execution, right? We'll see some example of it going forward. What is referential equality? So in referential equality, in case of referential equality, what we need to understand, in JavaScript, there are basically 3 ways that you can actually say two things are same or not. You can do equality between two things. One is like this operator, which is called loosely equality operator. The second one is like strongly equality operator, strong equality operator, which is like 3 equals, and the last one is like object.is, right? So these are the 3 things. Now in case of React, whenever there is a component re-rendering happening between 2 renders, we have touched base in our virtual DOM video, like there are various algorithms that React has through which React identify what are the changes and where exactly changes into the tree, so that it actually make an impact over there. That comparison, the changes comparisons happen using object.is equality method. It doesn't use either of this loosely equal or the strictly equal operator. It uses object.is. Now for numbers, it is very, very easy. So like we can say like whether 1 equals to 1 or not, true equals to true or not, for in case of boolean. But the problem comes, or the ambiguity comes, when it comes to object. Now in JavaScript, a function is also an object. Okay, array is also an object. An object is of course as an object. What exactly an object? It is something which has a reference in the memory, and now React has to figure out, like between 2 renders, when it comes to object, how to determine that the object that I'm dealing with right now, the previous render and this render are equal. If those are equal, I'm not going to do anything. If those are not equal, in that case, what I'm going to do, I am going to take certain call. So for example, in this use effect, if I'm just passing something called a sum function over here, now this is sum function. Function is an object, right? It has a reference in the memory. Now between two renders, this sum functions is going to be different. Now once the sum function is going to be different, it means in the next render what is going to happen is like this particular callback is going to get executed. Now if you write the sum function somewhere at the top, like function sum function has some body, you would not have changed anything. You would not have changed anything in that particular sum function apart from the fact that the argument of the sum function would have got changed. The exact definition of the sum function is exactly same, but argument would have got changed, and because of that, React will treat like the sum function has changed. Object.is is going to determine these are two different objects altogether between two re-render, and it is going to execute the callback of useEffect. Now, if you are doing something really heavy inside this callback of useEffect, it means that in every render, this is going to get executed, right? Also, in another case that I'm not sure if you have already faced, but I have faced, in my app building already, that passing a function like this, in case of you're using certain linting tool, use effect, and using some function inside this, you will get a linter warning that you are not passing that function as a dependency. The moment you pass that function as a dependency, you might get into an infinite loop kind of situation. Now to tackle this situation, use callback comes very handy. Now what we are going to write now, we are going to see certain examples through which we'll understand the use callback and the use memo much more clearly. So from theory, let's jump into the practical right now. Now let us take an example of this particular application. It's a simple application, okay, which is having a text box, and the purpose of the text box is like basically you type a name over here, it gives you a greeting like hello Tapas, and additionally what it has, basically it has a button and some kind of counter. Once you click on this counter also kind of grows. Okay, so this is what it is. So let's take a quick look into the code once. Very simple one. You have seen plenty of code like this in this React series already. So it has two state variable. One is like name for this particular text box and this counter for this particular counter. And then there is a method called getGreetings. Whatever the name you are giving over here, that particular name, we are just appending with an hello and returning from it as a simple function. And then of course this particular input box over here, which is nothing but this one. And there is a greeting box, which is actually this component, which brings this hello Tapas. We'll get into that eventually. And then it prints that counter, which is like this 1, 2, 3, 4 when I click on it. And then there is a button like, the +1. So what is doing every time I'm clicking on it, it is just incrementing the counter value by 1, and I'm printing that counter value over here. So this is very, 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 very simple thing. Now in the greeting box, let's get into the greeting box. What exactly greeting box is happening is like whenever I'm typing something on this, right? Whenever I'm typing something, the name state value is changing with this updater function, like our simple use state hook updater function by taking the value from this text box. So if I type Tapas A, the moment I type Tapas A, the name value is Tapas A, right? So it means that the get greetings, if I give a call to get greetings, the get greetings will be hello Tapas A. Now in this case, I am not giving a call to the get greetings, rather I am passing the function as a props to this greeting box component. So that in the greetings box component, I'll execute this one and then print the value of it in a h1 or some kind of tag. So let's say greeting box is take this particular function itself. It doesn't execute it yet. And once I go to the greeting box directly, I get this as a props. And once I get a prop, what I do basically, I do like, there is a state variable again. And, in this case, I am just executing this particular function. And the value whatever I am getting is setting into the state variable, and this value I am actually printing over here. Now you can tell like that, hey, you getting this function here again, you can directly kind of execute it somewhere here. Yes, I could have done some of this in a much better way, but I wanted to demonstrate that how use callback certain times can be helpful. So why the code is written in this fashion, right? So I am actually passing that function itself, executing the function in the use effect, and then whatever the value of the function, taking in the state variable, and that state variable I'm using over here, right? So that's as simple as that. So the value is getting, the pointer function is getting passed and getting executed. Now as I'm using this particular function is use effect, this is our case, the case that we just now discussed. What happened over here, like I have to pass this as a dependency, otherwise my linter is going to shout, hey, you are using something using use effect, but you have not declared that as a dependency. And I have to declare this as a dependency because every time my app.js re-render, the child component also may re-render, because this getGreeting function references would have got changed. In between two re-renders, this could be two different instances, two different objects, and when React does this object.is of this function, it will find these are two different references, two different objects, and it will call for a re-render. And it is happening. Let's prove that. Okay, why? Because let's talk about this one by one. Please take a look into this console for a moment. Now I'll refresh this application, and what I'll do, I'll start typing something. So if I type say A over here, it says hello A, and it print greeting box use effect. Okay, how does it happen? I typed A into this input box. The name is now A. Okay, I have passed this getGreeting over here in the greeting box. Of course, the state value got changed. That means component will re-render. The components get re-render means this greeting box now get a new copy of getGreeting, which means it is hello A, still not executed. Now if I go over here, I have a use effect. The use effect is printing greeting box use effect getting print. Now if I type B, again it gets printed, so it is 2. If I type C, D, for every typing it will be printed, because of course for every type this particular state variable, name state variable I am changing, and as I am changing the state name variable, the component will go for re-render, the child component also will go for re-render, and for every re-render this use effect will be called. For every use effect callback, this console.log is getting to get printed. This is perfect. This is how the React programming should happen, and it is happening. Now one more thing that I am going to do is this particular counter box. In this case of counter box, I am not touching this input box at all, right? Because I am just clicking on this button and I am a separate state variable what I am incrementing. I am not touching it at all. Input box I am not touching. As I am not touching the input box, there is no question that I am modifying this name variable at all. There is no question that this getGreeting is getting changed. So there is no question of this particular use effect is getting called, because getGreeting is not getting changed. But let's see the magic. When I click on this +1, you see it's getting called. I click on +1 again getting called. Click on +1 again getting called. Now this is little bit annoying because I am not changing name. So because of that, my getGreeting function is not going to get changed, but still I am seeing this user getting called again and again. Now this kind of problem is going to cause a performance thing, right? Think about the case that getGreeting may be something which is little bit expensive, but you are calling this unnecessary of clicking on a button which is like completely unrelated, right? Now how are you going to solve this problem? We are going to solve this problem by using a very simple trick, the trick of using useCallback. What we can tell, like my component is like this getGreeting function is depending on name. So unless the value of the name changes, let's not execute getGreeting at all. Because if the name value changes, if somebody is putting something into this box, then only name value changes and then only you execute. But until that is happening, don't execute at all. Now to do that, we have to do some signature change. So what we are going to do, we are going to like same thing, getGreeting, but here we will be using useCallback. And useCallback takes this function, let this function be as it is, we are not going to change. And then we are saying that it is depending on dependency parameter called name. So this is the only change that we are going to do. So see, we have learned useCallback takes a function and it returns the same function to you only when the name changes. So it means the getGreeting will have a function only when the name changes. And the getGreeting function I am passing how I was doing before. But in this case, I will be getting a new, completely new function, right? Not the cached one, only when the name changes. This is my logic. And if that is the case, if it is the same function that is getting passed, That means my use effect, whenever there is a comparison happening in the use effect, in its dependency array, it will find that this get gettings is the same object, is the same function between two renders. So there is no use of again executing things over here. So let's see how this is going to change thing for us. We'll save it. Okay, so things have appeared. So right now I will change the name. So say A, B, C, D. Great. So for A, B, C, D, it has changed because of course I have changed the name, and every time I change the name, useCallback gave me a new copy of the function. That is what I have passed, and it is re-rendering. But now if I click on this, do you see it is no more printing this getting use effect? So it means every time I'm clicking on this, the name value has not changed. So it has written the old copy, the cached copy of my getGreetings function. That is where I am actually winning in terms of performance. That's why useCallback is very important. You are using it correctly to save from certain unnecessary rendering, unnecessary computations for you. Alright, so useCallback is done. Now we are going to see an example of useMemo. Okay, so in the useMemo, look at this example. So for example, I'm getting some kind of user data. Let's like take it in this way, like this, and user data I'm taking over here. So, and after getting the user data, I am calling a function called getAgeAnalytics. Now this function, let's assume that it takes a lot of time to perform the analytics and give me the age data, right? Now this function I can call like this, right? I can get the age data, and then age data I can use in my JSX. As simple as that, a simple React component. But problem is, every time this guy gets re-rendered, for some reason, I am actually computing this. And for the same users, I am going to get the same age data. There is no difference of it, but I am computing. So if this is taking say 3 seconds, 4 seconds or 5 seconds to compute, on every render, I am losing that 5 seconds. Okay. Instead of doing that, what we can do is like, we can use something called useMemo. It's as simple as our useCallback that we have seen. So in this case, what we are doing here, I am calling this useMemo, but this getAnalytics, I am actually, this particular function I'm keeping here. Instead of here, I'm putting it over here, and then I'm putting users as a dependency. So it means until and unless this user's data changes, this is always going to return me a cached copy, a already stored, in memory stored copy of the getAgeAnalytics function execution. It is not going to send me the newly computed value every time. Okay, and in case of useMemo, it is going to send the return the executed value, the computed value. In case of useCallback, what you have seen is like it used to send the function, but in case of useMemo, it is going to send me the value. So this is another example where you have to remember, like if there are certain things which is like very expensive, in that case alone, you will be using useMemo, passing this function over here, and then the dependency. So if the dependency changes, only then this is going to get recomputed. Otherwise it is not going to get recomputed. It is going to send you the old value that you can keep using. So your component rendering is much faster. Okay, so this is all about our useCallback and useMemo. Now before we end, I just want to call out a few things. React takes care of your performances much well without you do a lot of stuff. If you are writing useCallback and useMemo in your application code, you should have a very valid reason why you are doing this. You have to think twice, is this the right case where I should be writing this useCallback, useMemo? And most of the cases are around the use cases which I have spoke in this video. If you unnecessarily put useCallback, useMemo, in your component, you have to remember that React is performing an extra operation. It is not free. React is caching that particular information, and every re-render, React is actually checking a dependency, then finding out whether we have to execute or not. So every if else, even if a simple if else block, it's going to take some extra milliseconds, right? Probably an extra nanoseconds. Now, if the things are much bigger, it is going to take much more time. So don't make React work unnecessarily wherever the useCallback, useMemo is not required, because otherwise React is going to again figure out a diff between a cached value or the currently executed thing, whether dependency changes and all these things unnecessarily. So please use useCallback and useMemo wisely. Don't use just like that because you have to use it. Maybe your component is re-rendering for some other reason. Maybe there is a timer which you have not cleared off from use effect. There could be various different situations. Look into those first, then you really think about using useCallback and useMemo. So that's all about this one. I hope you got a good grip of use callback and use memo, go ahead and start practicing them.